Okay, well, welcome. Good morning, everyone. Today is Physics 102 practical class. And today, we're going to attempt. So welcome to Physics 102 practical class by Success. And today, we're trying to teach our students graph plotting. Graph plotting is a very important part of our physics practicals because every practical you're going to carry out this semester, you'll be required to plot a graph, except experiment M1. There's only one experiment in your manual that doesn't require a graph plotting. Experiment M1. But from M4 till the end of your experiments, every experiment, after finishing carrying out your experiment, you're going to record your values. You're going to calculate. There are some calculation questions after each experiment. And after the calculation, the last part is you'll be asked to plot a graph of one of the quantity against the other quantity. You're going to be asked to plot a graph of one quantity against the other quantity. Now, class, so in graph plotting, the key things we'll be looking at today, first of all, is determination of scale, how to determine the right scale. We're looking at determination of slope, Of course, your title of your graph is very important. Number one, the title of your graph. Any graph plotted without title is already 0 marks. No matter how fine your graph is. Without title, you get 0 in the marking scheme. Without title, you get what? 0. Also, any graph without stating the scale you use, 0. Because imagine over 1,000 students and the lecturer has to start figuring out what scale did this student use. It doesn't have that time. So it's your job, even for secondary school, it's your job to write down the scale. Where do you put the scale? The scale should be below, while the graph title should be up. So you write your title of the graph. Of course, there's a space in your graph sheet for your dates. There's a space in your graph sheet for your what? Dates. Then title. Title of your graph, you can say graph of L against T square. Now what you're going to say, this now you're going to write it. Now they say plot a graph of L against T square. You are going to say graph of L on the y-axis against T square on the x-axis. Graph of L on the y-axis against T square on the x-axis. Class, anytime you have to plot a graph of A against B, note that the first quantity mentioned is going to be on the y-axis. The second quantity mentioned is going to be on the x. So they say you should plot a graph of D against E. D will be on the y-axis. E will be on the x-axis. Very, very important. Very, very important. So please take note of that. Before you start plotting, because of time, you might forget. When you start plotting the graph and making several mistakes, you are cleaning, and then time is up. You forgot that you have not written your title. Don't make that mistake. Write your title of the graph and your dates. Graph of L on the y-axis against T square on the x. Now, before you start plotting, of course, if you have started plotting, it means that you have a scale you're going to use. That's why you're plotting. Because you cannot plot your graph without scale. So if you've gotten your scale, so you don't also forget, because it carries marks. Go below and write your scale. My scale, how many centimeter represents how many units on the y-axis? How many centimeter represents how many units on the x-axis? So that's why I said we'll be determining the right scale, determine the slope of the graph. We'll also be looking at the vertical slack or scatter. The vertical scatter is called W. Vertical what? 4, we have the range. You can be asked to calculate the range of your graph. The range is R. Range of your graph is what? 5 is the error in the slope. The error in the slope. SG. Error in the slope. S. Class, this one is a formula, but you must have gotten your W and your R before you can get the error in the slope. The formula for error in the slope, we have 4W all over NR. 4W all over what? and R. I'll tell you what the okay, W means vertical scatter. Your R means your range. Your N means your number of what points? Your number of observations. N means number of observation. Error in the slope. Now the intercept class, intercept is where your graph, the point of intersection between your graph, that means your graph line, and the x-axis or the y-axis. The point of intersection. Where does your line intersect on the y-axis, or where does it intersect on the x-axis? Called intercept. So did your graph pass through the x-axis, or did it pass through the y-axis? If it passed through the y-axis, it means there's intercept on the y-axis. If it passed through the x-axis, there's intercept on the x-axis. So sometimes your graph can pass through both the x and the y-axis. That means you're going to have intercept on the x-axis and intercept on the y-axis. Are we together, class? So please take note. Now, first things first, let us have a table of value so that we can then teach you how to use that table of value to determine to plot your graph and determine your scale. Plot your graph and determine your scale. As I said, the first example I'm going to give you today, I'll be using a very, very simple table of values so that you can understand for the first trial. Then the next one, I'll be going straight to a real practical value where you'll be more tested. But let's start with a simple one to make everybody understand what we're doing first. So we're going to have, let's have L here. And let us have T square on this side. So, of course, in your table there will be other parameters, but let's focus on the two parameters we're going to try to plot. Remember last week, you had T1, T2, T3, T4, then mean T, right? Yes, then you still have this big T and the T square. But let's focus on the two parameters we're going to be asked to solve, which is L against T square. Let's take very simple values first. Class, while we're doing that, I hope we have a ruler. Get a ruler because I'm going to ask you to measure. I'll tell you how to calculate a very clean scale that can fill your graph. Because you're going to help me on your graph. Everybody bring out your graph sheet. On your graph sheet, you're going to measure the full length of your graph vertically and the full length horizontally. Tell me the value in centimeter, and we're going to divide it by the number of observations you have to get a full-fledged graph. It's a very easy, clean way of plotting a neat graph. If you apply this approach I'm teaching you now, you'll be very fast in the lab. While others are trying to figure out how to plot their graph, you're already done. Are we together? So get a ruler. If you don't have a ruler, borrow from someone beside you. Measure the full length of your graph vertically. Record it. Measure the full length of your graph horizontally. Record it and keep it. I'll tell you what we're going to do with it. I'll tell you what we're going to do with it. Now, in your graph, class, your graph is in boxes like this, right? Something like this, right? Now, the first 1 point in this side, the first width, the first box, don't use it, and the last box, don't use it. So on this side of your graph, so what I'm saying is that so that you will not start plotting your graph on the edge of the paper. Do you get? Give the first 5 centimeters or so, better than a ruler. Give that space. That's where you start plotting from. Also below, the last line below, leave this space. So there should be a space here and a space. So measure, so in this space here, it means you're measuring, if this is your full graph, there must be a space up here too. Because it's this space up here that you might need to write your title. In case your graph sheet, there's not enough space on top to write your title, your dates. Are we together? This last space below now, you will not be your scale. Your what? Scale. So you need space. So if you use the full graph space, depending on how they design your graph in your book, you might not have space to write your title and your dates. So some people even leave 2. Some people leave 2 boxes up like this. Some leave 1. But there's some kind of values you have in your practical that you might need all the boxes. You might need as much boxes as possible. Do you understand? To stretch your graph. So don't start plotting from the edge of the paper. Do you get my point? And the edge on this side, don't start plotting from there. So give one this thing, then count from here. Measure from this place now, your ruler, horizontally. How many centimeters do you have? And vertically, after leaving this space and this space below, how many centimeters do you? So my graph will be in between this this region of your graph. I hope you're following with your graph sheet. Your graph will be within the region of your graph. So keep that. So when I ask you, you tell me. So you measure the number of centimeters vertically and horizontally. Now, so let us say we have L as 120 centimeter, L as 100 centimeter, L as 80 centimeter, L as 60, and L as 40. So we have L as 120 centimeter, L as 100 centimeter, L as 80 centimeter, L as 60 centimeter, and L as 40. Someone should help us with one of the. Remember that in that last week's practical, we had 4 tables of values. Do you remember? I told you we are plotting 4 graphs in M4. Do you remember? If you were around last week. Go back to your practical notes. Give me table 1. What are the values for T square in table 1? I gave you last week. Okay, for 120 centimeter, table 1, what do you have there? Quickly, for last week, yes, table 1. We have table 1, table 2, table 3, and table 4. Remember? Okay, if you missed last week's class, they're almost done with the editing of the video. I'll upload so you can watch. If you're also watching online and you missed last week's practical class, yes, I'll upload they are almost done with the editing of the video. I'll upload it so you can catch up. Who has this table 1? Please go to your practical note. So for 120 centimeter, what's the T square? 4.7. 400 centimeter, what's T square? 4.2. For 80 centimeter, 3.222. For 60 centimeter, 2.46. 2.65. 2.6. For 40 centimeter, what do you have? 1.7 what? 3. No problem. So we have 4.79, we have 4.21, we have 3.22, we have 2.65, and we have 1.73. Class. And here we have 120 centimeter, 100 centimeter, 80 centimeter, 6 centimeter, 40 centimeter. Now, this is clearly going to be on our y-axis, and this will be on our x-axis. Now, you have measured the vertical axis. What's the total length? Someone should give me what's total length of your y-axis you want to use to plot. When you measure with your ruler, how many centimeter? This is not something you should be doubting. Now, just use your ruler and measure your graph. And dot the point. This is where my graph will start vertically. I mean, this will be the extent of my graph, verti, and this will be the extent of my graph, horizon. So everything I'm plotting between this region, I want to measure. So you measured your vertical. I want to use someone's zone. Everybody's zone might be different, but I want to use someone's zone. 20 what? Your own is 24 centimeter. Okay, let's work with our own 24. Class, try as much as possible for it to be a whole number. You cannot start your graph. The one you can control, why using decimals? The measurement you can control, don't use. You are the one starting the graph, right? You have not started putting values that will be confusing. See 4.47. These 2 points on 4.4 points, and you're going to plot the graph. 3 point, 2.1 points. They are not too far apart. Class, you can control this part of your graph. Take your graph sheet. Make sure that you measure a whole number. Let it be a whole number. Don't use the decimal to start. So let the length of your graph vertically and horizontally, let it be a whole. You can control where the extent of your graph. Okay, I want my graph to be from this point to this point. So this is where my y-axis will start like this. And all my scale, every of my values on the x-axis will be on this. Also on your y-axis, it's supposed to be here, but permit me to use this because it's right. There's something written here. On my y-axis, I'm going to start from this point to this. Let it be a whole. It means that anything above here, below here, and on your x-axis the same thing. Let it be a whole number. Let it be a what? I know I want to be a whole number. Do you know why? Because now you're going to say. So this is on your y-axis, 24 centimeter. The highest value on your y-axis is 120 centimeter, and the lowest value is 40. So class, the difference in the number of observation vertically from the highest point to the lowest point, you're going to say 120 centimeter minus 40. So class, the difference between my highest and my lowest point is 80 centimeters. 80 what? 80 what? And class, so all this 120, 180, and 60, and 40 must fill this 24 centimeter space. Now, how many observations do you have, class? You have 5. You have what? 5 observations. You're going to say this 24 divided by 5. And this 80 divided by 5. 24 divided by 5 and 80 divided by what? 5. What is 24 divided by 5? What is 24 divided by 5? Now, another thing I can advise you to do to make this easy for you. Remember when Mr. Desi was talking yesterday, said this practical thing, there's always room for what? Error and adjustments here and there. Someone that got 24 can easily extend and achieve 25 centimeters. And achieve what? 25 centimeters. No, you can't. The book is in my bag. Yes. No, not long. Achieve 25 centimeters. So that 25 divided by 5. Class, is it not smart to say 25 divided by 5 is what? So you have 5. If you can't get to 25, you can reduce it to 20. 20 divided by 5 is what? 4. It will still cover a whole expansion of your graph. Now, 80 divided by 5 here is what? 16. So you are simply going to say 5 centimeter is going to represent 16 units. Represent what? And you have filled up your full Y scale. Is anybody, you are lost? You don't understand? I'll come again, don't worry. Class, let me come. This is your L axis, 120, 100, 80, 60, 40, right? What's the highest point on your L axis? What's the lowest point? The difference between the highest point and the lowest point. 120 minus 40. 80. So what it means is that for your whole y-axis, there's the difference between the highest and lowest point, 80. And how many number of observations do I have? 1, 2, 3, 4, 5. It means that in my y-axis, I'm only going to have 5 points. I'm going to have what? On my y-axis. From secondary school, do you remember that sometimes you used to plot graph and watch class? You know, someone can start plotting graph, and in his graph, he'll be putting 200, 180, 160, 140, 120, 100. See, the highest point on this L axis is 120. It means that from this 140, 200, nothing's going to happen in his graph. Does that make sense? Your graph will now be short, dwarf graph. Dwarf, we have called dwarf. And when you plot dwarf graph, you have dwarf results. Are we together? Because see, from 140 to 200, you're not going to plot anything in this side. So your graph will just end here, like very short, very. So I'm trying to make sure that your highest point on your graph is on your tables. Follow me. The highest point on your table is almost at the highest point of your graph. So your 120 is stretched to the. What's the point of some graphs? People will plot graph. A lot of things on that graph is not in their table. They will not use it. They will never use it. What do you need 200 for? Is it in your table? Is 180 in your table? 160 in your table? 140. The highest point is 120. There's no even space for the remaining 60, 40. Because I've already used everything for things that you don't need. So this is my method. It's going to help you to do what? To maximize your graph space. So how do you achieve that? How do you ensure that you don't have useless or unnecessary points on your graph that you will never use? Take the highest point on your L axis and take the lowest point on your X, on your Y. 120 minus 40. 80. So the stretch of your graph is between 120 to 40. This lowest is 140. And the S is 1. So what you're just going to say is, if this is your graph now, this is 0, 0. The next one now will be 40. Next one now will be what? 60. Next one will be what? So that 120 minus 40 is 80. 80 divided by 5 is 16. So class, this is 16 units. 16 what? You're not going to go and ask yourself, we measure the y-axis, the line on our y-axis. You got 24, I say push it to, that means add one more to make 25. If there's no one more centimeter to add, then reduce it to 20 centimeters, you're still good. Don't forget, your graph at least should cover 75%, 3 over 4. 3 over what? So if 25% is not there, you're still good. The whole 25% of your space is not used. You're still, but it's 75%. So if you're 25, if you don't want to use 25, you can use 20 centimeter. Now you can measure only 20 centimeter point in your y-axis they are going to use. So two of us can have different scale and we're both correct. Class, graph is not like, there's no final answer, one common answer for everybody in graph, right? Your scale can be from my son, we are both correct, we are both correct. Now follow me. So you measure your y-axis, everybody will be on your y-axis, right? So measure your y-axis, the point you are going to use. Remember, when you're measuring the point on your y-axis, leave some space up, small space up, and leave small space. Then point the two places. This is where my y-axis starts from. So from here to here. So this is 25 centimeter. You're now going to say for every 5 centimeter, because you have 5 points. This 25 centimeter you measure 25 centimeter, right? Divided by, why are we dividing by 5? Because we have 5. So this whole space, we want to divide into 5 different positions. 0.1, 0.2, 0.3, 0.4, point. Oh, we have only 5 points. 40, 60, 80, 100, 1. We don't have to put points for 0 because 0 is starting at the origin, remember? So 40, 60, 80, 100, 120. So when you have plotted your graph, when you have done that, you now say 25 divided by 5 is 5 centimeters. It means for every 5 centimeters, you're going to have 16 units. For every 5 centimeters, you're going to have what? 16 units. So you're going to say 5 centimeters represents 16 units on your graph. So if you have your graph now, you have this. If this point to this point is 5 centimeter class, so this is the origin. This is now 40. Because of this space, let me make it. Let's see, this is the origin. This is now 40. Follow me. Let me show you something. So your graph started here like this. So this is 0, 0. Maybe this was this point to this point you measured in your graph. There's this space up, but there's this space down, small space. But this was the point you're going to use. I'm going to use this point to this point. And this point to this point in your graph is 25 centimeters, 25. It might not be 25 in your own, it might be 20. You understand? The numbers can vary. But understanding matters, right? From this point to this point is 25 centimeters in my graph. So 0. And I have only 5 points. 1, 2, 3, 4, 5. If from here to here is 25 centimeters and I have 5 points, won't I divide the 25 centimeters divided by 5? It means that for every, if this point is 5 centimeters, 10, 15, 20, 20. For every distance between one point to the other is 5 centimeters. Is what? The distance between one point to the other is 5 centimeters. So your scale is telling the lecturer what's the value for every 5 centimeters. For every 5 centimeters in your graph represents 16 units. 5 centimeters represents what? 16 units means that if this is 0, 0, this will be 16. This will be 32. 32 plus 16. 48. 48 plus 16. Oh, sorry, this is not what's going to happen here. We're going to say 5. Where's the units we have? Sorry, class. What we are going to say is this. Look up. The distance, the point between this 40 and 60, 60 and 80, 80 and 180 and 100 and 120. So I've already got into 5. So we have for every 5 centimeter now. We've gotten our measurement for each point in the graph. The next thing we need to figure out is how many units will this 5 centimeter represent. For each 5 centimeter, how many units will represent to make sure that we arrive at 40 to 120. How many units will this 5 centimeter represent? We can easily say that let 5 centimeter represent 20 units. Do you know why? Because easily the distance between this our 2 point is 20 centimeter each. 120 minus 100 is 20. 100 minus 80 is 80 minus 60 is what? 60 minus 40 is 20. So we're now going to say for every 5 centimeter we have 20 units. So this is 20. This is 40. This is 60. This is 80 and this is 100. Then because we have our highest point as 120, you can easily add another 5 centimeters. Remember, you left space. You can easily add another 5 centimeters and say 120. And then you see that you have filled the whole length of your graph vertically. So your scale on the y-axis now. Why you need to be good at this? You see that it takes time to figure out. And this is one thing that takes time, students' time in the lab. Imagine you doing and wasting all this time in the lab just to plot graph. Meanwhile, your practical has already taken enough time. So you need to, this one aspect, graph plotting, I say we'll teach today that you must figure out before you enter the lab. Figure out, be very good in graph plotting already. Be very good in graph plotting so that when you enter the lab, you'll not start second guessing yourself. You'll not start second guessing yourself. So with this now, our graph can be 40. Class, you know that thing that can happen? Let me teach you something. If I wanted my 120 to fit into this place, see what I could do. If I wanted my 120 to fit into this place. Class, there's what we call it, something you can do to your graph like this. I can use this place to cover 0 to 20. This sign is almost like a sign to shorten your graph. Physics, practical people use it a lot. And I don't want to put this 20 here. I want my graph to start from 40 so that my graph will start early. Because it means that if I use what I'm using now, if I use what I'm using now, follow me. If I use what I'm using, it means that my first point, 40, is going to start from here. It means I've missed all this part of my graph. Do you get? So what you can do, watch. You can come in here and say, you can do a sign like this, which has covered the first 20 centimeter, and then you come in here and you say 40, 60, 80, 100, 120. How many of you know about this from your secondary school? You know about this. You know that this is possible. You know it's possible. You know it's possible. Okay. I want to be sure. Let's know because everywhere is quiet. I see how what is going. Very, very what? But university will teach a lot of things. You can, so that's why sometimes someone that doesn't know how to plot graph, will just plot graph and everything is short. Because that's what you could have done to extend the graph. But because you don't know, you don't know. When we come to line of best fit, I'll teach you another thing that you can do. You can manipulate. Yes. No, now I'm recording. Write the what you want to write. Those questions asked, they take time. They slow down the class. Write what you want to ask down. Eh? So I just shortened this. And what do I have here? 40, 60. So by shortening this, I've told anybody that's marking that some points have been what? Have been compressed. Have been what? So that my graph can start from the lowest point as possible. Are we together? And 40, 60, 80, 100, 120. So now this is just y-axis. You've not plotted your graph yet. Figure this out before you enter the lab. It takes time. It takes, no matter how good you are in graph plotting, anytime you meet points, you have to think afresh. Because you cannot just know one. There's no one rule fits all. Because every day you have different values, different tables, right? So even if you are very good in graph plotting, I can give you some set of points that will challenge you. You have to think again. Because you got yesterday's graph doesn't mean you get today's graph. I mean, I've taught this graph in several years. But if you bring a new point, I still have to think again. That's why it's taking time. Do you understand? So figure it out before you enter the lab. No, make sure you are very good at it. Now, let's go to the x-axis. Who has measured the points you want to use on the x-axis. What's the length of the x-axis? I would like a whole number. I would like a whole number. Who will measure the length on the x-axis? I want a whole number. 15 centimeter. 15 centimeter. Okay, good. 15 centimeters. So on our x-axis, she has decided to use 15 centimeter width. That means this is the only part of my graph I'm going to use. Make sure that it's not too short, it's wide enough from this. If you have 15 centimeter in your own graph, now your own could be 20 in your own graph. You could be any, you understand? The numbers can differ. You're not going to say 15 divided by how many points? You have 5 points. You have what? 15 divided by 5 is 3 centimeter. It means that you're going to divide this 15 centimeter space in your x-axis to use your ruler and measure 3 centimeter. So 0, 3 centimeter, another 3 centimeter. Every 3 centimeter represents a particular unit. We now need to go and ask ourselves, how many units does 3 centimeter represent to ensure that our graph is well extended? Class, if we say for every 1.5 units, if we say 3 centimeter represents 1.5, that makes sense for this graph. Do you know that? Because if we have means 0 to 1.5, 3, right? 4.5, 6, and then 7.5. For every 3 centimeter, it represents 1.5 units. Represents what? Every 3 centimeter represents 1.5 units. So from this point to this point of your graph, it means that your graph, because what's the highest point? 4.7. 4.7 will still be between this place and this place, right? It means there's only one part of this, your x-axis you did not use. It's still fair. It's still what? Remember, 3 over 4, 75, 75 what? 75%. So you're going to say 3 centimeter represents 1.5 units on the x-axis. And 5 centimeter represents 20 units on the y. You're not going to plot your graph. You're going to do what? You now use this scale to plot your graph. Is anybody lost? I should come again. I'll come again. I'll come. Is it this? Okay, the y-axis is clear now. It's the x-axis. It's the x-axis, right? Let me come again. Class. I hope at least the part of where that she told us she got 15 centimeters. You understand that part, right? That one is simple. It's your ruler used to get that one, right? For this 15 centimeter, everybody's answer can be different. Your own, you can say, no, I want to use 18 centimeters. I want to use what? You can say, I want to use 12 centimeters. So it can all be different. You get? So that is not a problem, right? But we're just using our whole 15. But I told you, try and make it a whole number as much as you can. And to the closest whole number that can divide your number of observations. Be smart in your plotting of graph. Make it to the closest whole number. Class, I'm sure it's not a coincidence that she chose 15. Because she knew that 15 divided by 5 gives you a whole number 3. You're smart. If she had 6 observations, she would probably have gone for 18. Right? If you had 6, you would have gone for 18, because 18 divided by 6 is 3. So you have to be smart. There's a bit of smartness involved in this. So for someone that doesn't know all this, now we'll go to lab and plot exactly what's in his table on his graph. Your graph looking so short. But if you just follow your table like that, and you just plot what your table is showing you, your graph will vary, because some points are very, you understand? So what we did is that measure the part of your graph you like to use. Having in mind that you have 5 observations. So carefully pick out a whole number length that can easily divide 5 to give a whole number. So this person picked 15 centimeters. You can pick 18. You can pick, 20. 20 can still divide 5 to give 4. So 15 divided by 5 is 3 centimeters. It means that you're not going to rule that. So if this is the point you measured in your graph, you can even be doing applying. You can be doing that. If you measure this point in your graph now, so this is 15 centimeters, right? Every 3 centimeters, mark a point. That's point 1. Another 3 centimeter point, point 3, point 4, and point. If you measured well, you should have only 5 points after every 3 centimeters. But 15 divided by 5 is 3. If you use a 20 centimeter, 20 divided by 5 is 4. It means after every 4 centimeters, use your ruler 0 to 4. Okay, 0.1. 4 to 8. 8 to 12.3. Please, don't look as if you've never done graph before in this life. It's just that you don't understand in second. It's not that you have not done it, right? So some of the ideas should be there. How did you write WAEC? You did practical in WAEC now, physics. So don't do as if you've never plotted graph before. I'm surprised some people don't know this. That you just reduce your graph. It's called graph reduction, so you can accommodate. Allow for accommodation. Only few people need it. But it's fine. You see why I told you that when I first started this class, that first week, I told you guys that the problem is that many secondary schools do not teach these things very well. Normally, they shouldn't be teaching you graph now in year 1. Someone that has done SS1, SS2, SS3. We shouldn't be teaching you graph now. Are we together? Are we together, class? SS1, you had first term, second term, third term. How much was your school fees first term only? I'm sure it's more than 50K. Or 30K or 40K. Just one term. And you did first term, second term, third. SS2, SS3. But you're in university and then we're still learning it. It's still fine. Now, so let's go. So say 15 divided by 5, 3. So for every 3 centimeters, you ask yourself, how many units do you want it to represent? How many units do you want it to represent for every 3 centimeters? Someone should help me do 4.79 divided by 5. Let me see if I can give you another better way to understand. 4.79 divided by 5. .958, right? If you don't even want to use 1.5 for like every 3 centimeters represent 1.5, do you know that I can actually use every 3 centimeters represents 1 unit? Do you know I can use it? That every 3 centimeters represents what? I'll just say 1, 2, 3, 4, 5. Class. Every 3 centimeters represents 1. It doesn't mean that this 3 represent 1.5 was wrong, but it was not. Class, you can have 10 graphs, 10 possible scales. So in this aspect of learning graph, you have to be flexible. One aspect is not wrong and the other aspect is what you prefer. Do you know that every 3 centimeters, let it be 1 unit. So 1, 2, 3, 4, 5. What's the lowest point on my graph? 1.73, it enters. So you know that 1.73 will be somewhere around there. This kind of scale allows you for easily manipulation. Especially if your point is not fitting. Because it's now left to you to now decide where is 1.73 between 1 and, you know it's between 1 and 2, right? So maybe you put it here and then it's not joining a particular point. You can just shift it a bit, knowing that you are still between 1.79. 1.73, sorry, 1.7. The next point is 2. Where is 2.25 going to fall between? Between 2 and. So the middle of this line is 2.5 clearly, right? So if this is 2, this must be 2 point. So 2.65 must be, anything after this 2.5 is 2.6. You pick your next line. See that if it's not joining this, you can easily what? 2.65. 3.22 must be between 3 and 4. Between 3 and 4 is 3.5. 3.22 must fall before 3.5. Do you agree? 3.2 is before 3 point. So you must fall somewhere 3 point. So if this is 3, 3.1, 3.2, 3.3, 3.4, then 3 point. 3.6, 3.7, 3.8, 3.9, then 4. So 3.1, 3.0, 3.1, 3.2, 3.22 must be somewhere here. 3.2. I'll tell you how our vertical scatter comes about. Follow me. What's the next one? 4.21. If this is 4 and this is 5. 4.4 between 4 and 5, 4 point. Do you agree? 4.21 must be between 4.0 and 4.5, right? 4.1, 4.2. 4.21. Somewhere here. And the last one. 4.79 must be after 4 point. 4.79 must be after what? Or if it's 4.5, 4.7 must be somewhere here. And it's one that is 120. And you've gotten your 5 points. Now, this cannot be accurate because this is not a real graph. I'm just guessing the point. But in a real graph, you can actually get it. But let me now show you what will happen. After you've gotten your 5 points now, Plus, I hope this exercise zone is clear now, right? I've used another example. I'll give you a table to plot, and I'll go around. Everybody be with a graph sheet. Please, learn it now. Learn it. You can borrow. Some people bought a full book. If you don't, just test one tier one for you. Be with a graph sheet. You can use pencil, your pen or pencil. Then you're not marking it. Just make sure you are plotting. Even if you don't have pencil, use pen. Learn it now, class. See how long it's taking, and I'm teaching it. Imagine you that you're just going to laugh for the first time. This guy alone can take one eye if you're not careful. And your group member will not help you in this one. You can be in the group, someone will carry the practical for you, give you values. But your graph, you plot it by your... That person also has graph to plot for himself. And everybody's in the same scale in the group, they will know that you all copied. They might not know that you copied from your calculation, not from your tables, but from your scale, they will know that you call. You can be in the same group, your value should be the same, yes. Your calculation may be the same, yeah, but your graph, if everybody's plotting the same graph, the same scale, lecturer knows that you copied. They just give you flat marking. Everybody is 1/10, 1/10. You copy the same. That's the easiest manual to mark for lecturer. Anytime lecturer sees that everybody has copied, thank you. You've made my work better. I don't need to think to mark. So you wrote the same things, right? Everybody flat. They give you flat marking. 1/10, 1/10, 1/10, 1/10, 1/. So your scale, don't allow it to be someone else's scale. I'll soon give you a table of value. Before that, let me break all these things down. Now, class, so we have marked the determination of right scale. When I give you the classwork, as I'm going around, if you still have questions, I cannot be answering you, right? Let it be an hands-on class. Are we together? So I'll be going around. As I give you the classwork, you have questions, I cannot be answering you. Now, determination of slope. Determination of what? Class, you will not take the... I usually like taking the highest point and the lowest point to form your triangle. You form your what? Triangle, and you take your slope, M. Slope is the easiest thing to get. You just say y2 minus y1 all over L2 minus L. That's the change in the y-axis divided by the change in the x. At least if there's one thing that even when we were in school back then, even if we did not know any other thing, everybody knew slope, right? It is the simplest part of graph. Just changing the y all over changing x. It was the easiest part of graph to understand. Now, the one I know that most people may not know is this vertical scatter W, right? Let me explain. Let me show you. How do you determine your vertical scatter? You must determine from the graph. Class, follow me carefully. Because without this W, you cannot get your error in the slope. Class, let us say this is your graph. Do you remember that sometimes in secondary school, if the line doesn't meet, you ticking the point. Do you remember? You ticking it so that you can enter. You ticking it like this. All these things are normal things, they are correct. Now, let us now say that there are 2 points that did not meet. These 2 points are not our line of best fit. Class, for your line of best fit, at least 3 points should meet each other. At least what? At least 3. For your line of best fit. At least what? These 2 lines did not meet, class. So what we are going to do now. This line that did not meet on this side, you're going to use a dotted line to trace it. Follow me. And this line that did not meet on this point, use a dotted line. Are you together? The line that did not meet on this point and this side, you're not going to take your ruler, and measure the distance, because these 2 lines are parallel to each other. At any point you measure the distance, you have the same distance. Class, use a ruler to measure the distance between this line and this line. Vertically, make sure your ruler is straight. Whatever you get is your vertical scatter W. Let's say I measured this to this, I got 2.5. That's my 2.5 centimeter. My vertical scatter is 2.5. Shall I come again? Let me come. Class, your graph has 5 points. Follow me. Please look up. Your graph has 5 points. Among the 5 points, only 3 points met is part of your graph. Those other 2 points that were not included in your graph, you're going to draw what? A dotted line to represent them. So I draw a straight line that's parallel to the axis of my graph. On this side, and this other point on this. I'm now going to take my ruler and measure the vertical distance. That's the vertical scatter. The vertical distance between this point and this point is my W. Is my what? W. So let's say we have 2.5 hypothetical value. Hypothetical what? Class, is it better now? Is it better now? That's the W. Now, this is how you determine your vertical scatter. Now, someone should now ask me, sir, what if 4 points in my graph met? What if what? So this point was not there. It also met. It also did what? It also joined my main graph. It means that I'm only going to have one dotted line. I will not need this. My vertical scatter will just be this. Distance between this point and my graph. Distance between and my what? Will be my W. Will be my what? Likewise, if this point was on this other side and this point is empty, between this point and this point, vertically, make sure your ruler is straight. Will be your W. Now, what is your range of your graph? The range of your graph is the highest point horizontally and the lowest point horizontally. The difference between the highest point horizontally and the lowest point horizontally is your range. Class, we had a graph of L against T square, right? Who was on the x-axis? T. What was the highest point on our x-axis? 4.7. What was the lowest point? 1.7 what? 1.73. Good. So my range is going to be 4.79 minus 1.73 R. The range will be what? 4.79 minus what? Is the range of your graph. Is the what? Now, error in the slope. Error in the slope is now easy because you've gotten W from here, vertical scatter. You've gotten range R all over N. N is number of observation is 5. Number of observation is what? Because you had 5 observations, remember? 120, 100, 80, 60, and you had 5. So N here represents what? Number of. You will now use it to determine your error in the slope. So SG will be equal to 4 times W all over number of observation 5 times your range. Difference between this and you have your error in the slope. Class, what is the importance of the error in the slope? Class, when you are doing your calculation, if you have been asked to calculate the error in the slope, when reporting your manual, let us say that the slope of your graph is 0.956. Class, it is wrong to just report your slope like this. You are not going to say plus or minus the error in the slope. This is how you fully report your physics practical. Plus or minus what? Let us say after doing the error in slope, you got 0.29. You now say 0.956 plus or minus 0.2. This is your full slope. To record your slope in your manual, to get your full mark, I'm telling you this now. You're going to write your slope plus or minus the error in the. How do you calculate the error in the slope again? 4W all over what? N. W represents your what? Your vertical slack or vertical scatter. Your N represents your number of observations. Your R represents your what? Range. What's the range again, class? Difference between the highest observation and the lowest on the X axis. On the X what? Then last error. So then last intercept easily is what point, at what point in your graph does your graph cut across either on the X axis or on the Y? Very simple. You just measure the point with your ruler. That's why it's good that you have control of your graph from your scale, because you can easily pick points on your graph because you know what every centimeter represents in your graph, right? So you're the one that did the scale, you're the one that did the. So if this line is cutting across this part of my graph, I know what exact point is this on my. Okay, this is 0.2 based on how I did my scale. This is 2.3 based on how I did my Class, it takes practice to be good in graph. Practice makes. That's why I want our first practice to be in class today. Are we all with our graph sheets? You all with our graph sheets? Okay, take this table down and plot a graph. I want to see different scales so that I can show our versatility. Let us not use only one scale. That's the question. Yes, your question, yes. Although I said I was going to go down. When I'm going around, I'll be answering questions because I'm recording. I don't want the videos to be too long. When I'm going around, I'll be answering. When I give you this last work now, I'll pause the video then. I know that I'm free, right? I cannot be answering questions, I'll be talking, and then it's being recorded. It's going to take a lot of time, and it's not good. The more longer the video, the more data you spend to watch, you get. So I'm trying to reduce your data for you. So when I pause the video, I'll give you classwork, pause the video then. I'll be going around. While you are plotting, if you have any question you couldn't ask, you are shy. Just call me, I'll come by your side. Sir, please, I didn't really get this thing you said. Sir, please, this, are we together? Is that better? So I'll be going while everybody's plotting their graph. So are you ready for the table? I won't give you a real practical table. I have a lot of practicals that have been solved already, as I told you. So I'll just pick from one of them in my manual here. And I'll give you table of values to plots. I'll give you table of values to plots. I'll give you table of values to plots. I think I have my manual here, field manual already here. Yes, I have two manuals here. So, if I start checking my phone will load all the messages. Let me just use my manuals. Yes, I said I'll answer questions. Remember, let me give this classwork first. When I'm going around, I'll answer. So, class, take this table of values down quickly. Take this table of values down. Which one shall I use? Let me use this one. This is already field manual that has been plotted. So we have H and we have T square. H is 10, 20, 30, 40, 50, 60, 70, 80. And T square is 5.42, 5.06, 4.75, 4.28, 3.88, 3.45, 3.13, and 2.75. So class, plot a graph of H against T. Plot a graph of H against T square. If you're following us online, do the same thing. And then plot a graph of H against T square. It's not time for me to go around. And if you have any questions that you couldn't ask, it's time for me to answer you. I think that's better. So let me pause the video now and then we can do that. Plot a graph of H against T. I'm sure this, after plotting the graph, determine the slope. Plot a graph of H against T square. Determine the slope. Determine the right scale, first of all. I want to see your scale. Determination of the slope. Everything we have been doing, you practice. Determine the slope. Give me your vertical scatter, your range, error in the slope. And is there an intercept on the x and the y axis? Let me know. So determine your right scale. Also title your graph as I told you. Title your. So let us practice. And when you get to the lab, nothing will phase you, right? You've already done everything in class. Okay, I'm used to it. You won't start thinking, what will I do in the lab? Oh, you know what to do. Title, your date. Put your date, your title. Determine your right scale, slope, vertical scatter, range, error in the slope. And is there, does your graph pass through the x or the y axis? Find the intercept on either the x or the y axis. Yes. Please. Class. In these 8 points now, if you have 3 points that meet, you have gotten your line of best fit. It means that there may be 5 wandering points. We can have up to 5 wandering what? Points. Points that did not meet your line of best. Class. Because we have 8 observations, right? I need only 3 to meet. The others we don't meet, you are still good. At least 3, at least. More than 3 is okay. I'm not saying there must be 3 that must meet. Then they don't know if it's 4, 5. 6. If 8 of them meet, I mean you are lucky. But rarely, it's very rare. If your graph is too perfect, they will know that you just draw graph. You just draw perfect graph. You do not follow the point. You understand? They should see a bit of uncertainty. Every measurement has a degree of uncertainty. So if it's too perfect, something is wrong. Maybe this is a planned graph. You planned your graph. Class. Let's say 4 points meet in your graph. Class, it means that there are 4 other points that did not meet. There's 1 point here. There's another point here. There's 1 point here and there's another point. Someone asked me, how we calculate our vertical scatter from this? Remember that the example I gave you, I only gave you 1 point wonder from this and wonder to this. Someone is not looking up. After they will ask, that's why it looks like, now ask, are you just entering the class? But the kind of question you will ask, because you'll be looking down. When you now look up, what you have done on the board, you are already lost. Please look up. The example I gave you before is if there's only one line that wanders to the left and one line wanders to the right. But look at this now. We have 8 observations. Let's say these 4 points meet. And 1, 2, 3, 4 don't meet. How do we determine the vertical scatter here, class? Class, we're going to draw one line on the left-hand side. We're going to pick the line that wanders the widest, the furthest away from our line of base. So there are 2, this point and this point are on this side, right? We're going to pick this point and draw the dotted line like this. The farthest point from the line of best fit on this side, and the farthest point from the line of best fit from this. Then take your ruler. Where is that guy that asked me for? How do we get W? Are you following? And measure. And do what? You get your vertical. You say? It mustn't be the point to the point. You know that if your line is drawn straight, if I measure the distance between this point and this point here, I measure here, it will give me the same thing. Give me the same. The distance between 2 parallel lines at any point is a rule, is a geometry rule. You did geometry in secondary school now. 2 parallel lines, all these angles, and you did all those things. If you measure it at any point, give you the same vertical width. Now, who is done plotting their graph?